Hello everyone, welcome to Math Decoded. I am calling this problem solving session a think along series because I want you to do just that, think along with me while we solve problems together. If once I read a problem, you should pause your video and think about the problem, try to solve it. If you don't solve it, then come back to the video, we'll discuss it together. So the first example at hand is, write down the power set of the set K. So this is K, and K is given as 1, alpha and 0. So hoping you have thought about this. This is my given set K, and it is a set because I have defined the set properly. I said that it contains 3 elements, 1, alpha and 0. So given any element, you could tell me, given anything, you could tell me whether it belongs to this set or not. So this is a set, and we have to find the power set of this set K. We also saw that power set is the set of all subsets. Set of all subsets. So it's, first of all, it's a set of sets. So there will be many sets written together, separated by commas, and it will be contained in a curly notation, curly brackets. So this is the set of some sets. These might be some sets. So my power set will be the set of all subsets of K. So I'll remove this. So how do we find the subsets of K will be our next question. What is a subset of K? So A, given any set A, will be a subset of K if for all the elements in A, so for all x such that x is an element of A, that is x belongs to A, this should imply that it should always happen in such cases that x belongs to K as well. So we also say that A is contained in K. We read this as A is contained in K. A is a subset of K, whatever you want to call it. And by definition, it means that each and every element of A has to be contained in K. So we looked at the null set in one of our lectures because we took intersection of two disjoint subsets or disjoint sets, and we got a null set. So we know that there is something called the null set. Now we'll have to check whether the null set phi or this thing is a subset of K. Well, does it suit this argument? Does it imply that this is true? For all, I say that it does, but if someone comes up to me and says that the null set is not a subset of K, I'll ask them to produce an element in the null set, and I'll show them that that element is also contained in K. So they wouldn't be able to produce such an element, and hence I'll be still correct. So this type of argument, the argument that I just gave, might be new to you. You can listen to it multiple times again, but this is called a vacuous argument. Vacuous argument. I'm not sure about the spelling. So vacuous argument, right? Vacuous argument. Vacuous is a synonym for empty or null argument, because this argument is just that it's an empty argument. If I say that x belongs to A, then x has to belong to K. But x does not belong to A to begin with, then x may or may not belong to K. I don't care about it. My statement is still correct. We looked at these statements in mathematical reasoning playlist also. So all this will be clear there too if you want to go ahead and watch it. But anyway, we saw that null set is a subset of K. In fact, null set will be a subset of all sets, whatever you have at hand. Null set will be one such subset. So I open my curly braces and I put null set as a subset first, and then I'll have to search for another subset. Now this will be a child's play, because any given set, people would know how to call it, when to call it a subset. So given this set, given this set, everyone would agree that it's a subset because every element in this set is contained in K. So this will be true for alpha and 0 also. And then what other forms of subset will be there? 2 element subsets. So 1 alpha will be a subset, 1 0 will be a subset. And what about alpha 1? What about this? Well, this is the same as this because the ordering in sets doesn't matter. As we saw, it's just a collection of elements, so you don't need to write this again. So we avoid writing that, and we write one more 2 element subset that there is, alpha and 0. I think I have not written this. Yes, so there will be 3 2 element subsets, and there will be one more subset, 1 alpha and 0. This will be a subset of 1 alpha and 0 because of the same definition, because every element in this set is contained in K. So K itself will be a subset of K. And finally I close the curly braces, hoping that I have all the elements written. So this is called the power set of A. I am denoting it by P of K. This is read as P of K. We'll discuss why this is read as P of K in further chapters when you go and study about functions. But now you just need not worry about all that. You can just read it as P of K and take my word for granted. And you can also call this any set you want. I could also have called this S. So this is the power set. You should count the number of elements in the power set and just make some theory about it if you want. We'll have one other video of number of elements in a power set, number of elements in the power set in one of our videos. You can go ahead and watch that too if you are interested in counting the number of elements in power sets. So we'll go to the next example. So this is a mouthful. Let U be the set of all triangles in a plane. So U is a set of all the triangles you could draw. So this all three-sided polygons, all equilateral, isosceles, all these triangles, you just put them in a set and U will be all such triangles. And if A is the set of all triangles with at least one angle different from 60 degrees, what is A complement? This is the symbol for A complement. So pause the video, think about this. So I hope that you have some idea of an approach to the problem. So given that U is the set of all such triangles, I have to find, so I'll also write what A is given. What is A? A is the set of triangles with at least one angle not equal to 60 degree. I'll have to find A complement. Well, first of all, we need to understand that whatever conditions I give for A will be exactly reversed in the conditions for A complement. That is, if I say that A is my set with some property, A complement will be the set with not that property. Because A complement is whatever that is not contained in A, so it will be all the elements which does not satisfy that property. So doesn't this look awfully familiar to us? Because this is just what we are used to doing in negations of a statement. So given any statement S, we negate it by saying it is not the case that S happens. So it's the opposite case for S. So once we have the condition for A, to get to A complement, it is just enough to negate the condition for A. So now that we have simplified the problem, let us think about what the negation will be for the set of all triangles with at least one angle not equal to 60 degree. So even if one might be tempted to say that A complement is the set of all triangles with at least one angle equal to 60 degree, one might be tempted to say that you change the not equal to equal to while negating. Bear in mind that even if one angle is not equal to 60 degree, the other two angles may be still equal to 60 degree and the triangle might still fall into my A, because only one angle has to be different from 60 degree to satisfy A's condition. You could think of it as if I say that all the fans or at least one fan in the room is not working, to prove me wrong, you'll have to come up and say that all the fans in the room are working. Only then I'll be incorrect. So I hope that you understand that argument. You can listen to it again if you want. So actually my negation would be with set of all triangles with all angles equal to 60 degree. Only then you will prove that this statement is incorrect. So negation of this statement on the top is this statement at the bottom. Take your time, understand this, and please do not hurry or panic while solving these types of problems. So finally, what do we have? A complement is actually the set of all equilateral triangles, because all angles are equal to 60 degrees. So they will be equilateral triangles, right? So going to the next problem. So this is, so you have also been given U in this problem. U here stands for the universal set, the universe of all sets, universal. So what I do quickly is I don't even read the problem completely. I just plot a Venn diagram for me to understand the sets better. So I can draw a little Venn diagram over here. So my rectangle would denote U. So this is U, and this is the set of all numbers 1, 2, 3, 4, 5, 6, 7, 8, 9. But my A and B are given, and I can also see some common elements between A and B. So I'll draw A and B as overlapping circles, and let me fill up my elements now. So A has 2, 4, 6 and 8. So 2, 4, 6 and 8. And my B has 2, 3, 5 and 7. 2, 3, 5 and 7. And all the other elements will be contained in the universal set. So this will be 1, 2 I have already written. 3 is there. 4, 5, 6, 7, 8 and 9 is somewhere here. It's not contained in either A or B. So now I have my general layout of my problem, and whatever is being asked I can quickly answer now. So what are they asking me? A union B complement. So what does A union B complement mean? So A union B is all the elements in A and B. So you just collect all the elements in A and B. So straight away from the Venn diagram you could say 4, 6, 8, 2, 3, 5 and 7 is A union B, and complement of A union B would be whatever is not contained in A union B, which is just 1 and 9. So we just took the complement of this set and we got this. Now I hope the equality is correct. And what is the second sum? The second problem is A complement intersection B complement. Okay, so first we took the complement of A union B, which was this whole region, right? And now we are taking the complement of A and we are intersecting it with the complement of B. So let me draw this diagram again just for convenience. I'll not write all the elements, so I'll just draw A and B now. So A complement, say that this is A, then A complement would be this whole set, this whole region, and B complement would be this region, and what will be the intersection? Well, intersection seems like it that if you intersect these two things, think about it on your own too. So if you intersect these, you would again get back this region. So this will be a better way of just solving this problem. Other than just analytically writing down the answer, you should think about the Venn diagrams. So again, this is suggestive that we'll get the same answer. We'll get, or I'll write the whole thing. So A complement intersection B complement would be 1 and 9. This is the same as this thing. So maybe this is a coincidence we got. All the best for further lectures. Let us meet soon. Thank you.